So you cannot draw actual drawing, as you don't need technicality of that part in terms of the dimension. You need technicalities of that part in terms of their output and their limits. Now if you look at this energy conversion unit, you can see that we have not specified that how much height of the boiler is, we have not specified how width of boiler is, just we have specified that its inlet is at 25 degrees and the outlet is 23 degree. How it works? In the condenser, intake is 5 degrees Celsius, outlet is 7 degrees Celsius. From the turbine generator, from the boiler, 20 degree water would be given to the turbine generator. It will be go to the electric power output. Some sort of low ammonia pressure would be created, then it goes to the condenser and again got exhausted. But it does not look like the same in the reality, but it gives all the technical terms in sort of the necessity. We do not use the technicality of the condenser over here, that's a separate part, but we get to know that the inlet of the condenser is 5 degree and the outlet of the condenser is 7 degree. The process work like this. On this process the temperature is 20 degree, on this process temperature is 10 degree. So these are the basic diagrams which represents the symbol to represent all the technical things. This is exploded view. If you are drawing any sort of assembly, then exploded view is very much necessary. Some of you might have gone to the garage and you have seen a frame hanging in the garage that showing the exploded view of engine, that how it have been assembled. A basic exploded view I am just showing over here, that you are having assembly of this sketch pen, right? Basically any assembly is of more than one part can be a assembly. Now basic assembly I am saying that the sketch pen is one sort of assembly, I am saying that. Now I need to explode that how these two parts look like when they are not together. So what I will do, I will just explode them like this, that this is the cover cap of the sketch pen and this is the main sketch pen. So it looks like this. Now when we are doing any sort of exploded view, it will be on the same axis only and it can be assembled once more. So these kind of exploded view can be generated if we are talking about any sort of assembly. Now as we have talked that we will have the video for the geometric constructions. These videos have been created using the Cognifront software.
Hi, welcome. In this session, we'll study various methods to construct different polygons. First, we will construct a regular heptagon with side length of 25 mm. We will use inscribed circle method to construct this heptagon. First, draw a line AB of 25 mm. This is side length of the heptagon. Next, at point B, we'll draw a line BP perpendicular to AB and its length is same as AB. Then, draw line AP. Now with center B and radius AB, draw a quadrant AP. Then draw the perpendicular bisector of line AB, which intersects the line AP at point 4 and RAP at point 6. After that, bisect the line 4,6 to obtain point 5. Measure the distance of line 5,6 and transfer it above to obtain point 7. Draw a circle using point 7 as a center and radius of A7. Using compass, make 7 equal parts of the circle with side length as AB. So here is our heptagon. Thus, we can draw different types of polygons by using the intersecting points on the bisector of AB. For example, a square of side length equal to AB can be inscribed in circle drawn with the center 4 and radius as A4. We can also obtain a regular hexagon of side equal to AB. It can be inscribed in a circle drawn with center as 6 and radius as A6. Now let's draw a pentagon of side length equal to 30 mm. First we'll draw a line AB equal to 30 mm. Draw a circle with center as A and radius as AB. Similarly, draw one more circle with center as B and the radius as AB, cutting the circle 1 at C and D. Next, draw an arc with center as C and radius as AB. The arc cuts the circle 1 and circle 2 at E and F respectively. Then, draw a perpendicular bisector of line AB which cuts the arc EF at point G. Draw line EG long enough to cut the circle 2 at point P. Similarly, line FG is extended to cut the circle 1 at point R. After that, with P and R as centers and AB as radius, draw two arcs intersecting each other at point Q. Finally, let's draw lines connecting these points to complete the pentagon. Fine, let's study a simple method for constructing a regular octagon. The method involves inscribing a regular octagon in a given square. Consider the given square ABCD with side length equal to 50 mm. Now we'll draw the diagonals AC and BD intersecting each other at O. Then with A as center and AO as radius, draw an arc cutting edges AB and AD at point 2 and 7 respectively. Similarly, with centers as B, C and D and radius as AO, draw arcs to obtain remaining points. At last, we'll join the points 2, 3, 4, 5, 6, 7 and 8, 1, thus completing the octagon. So friends, I'm sure that you are now ready to draw different types of polygons in engineering drawing.
Hi, let's continue the discussion of geometrical constructions for line tangents and arc tangents. But first, what is a tangent? A line tangent to a circle is a line that is perpendicular to the radius and touches the circle only at one single point. The intersection of these two lines is called as tangent point. Now, where do we need tangents? In machine drawings, very often we will have to gradually merge a single line into an arc with a smooth curve, and also we have to connect two arcs with another arc, making the transition by a smooth curve. And this is where we need tangents. We'll proceed with explaining the construction of an arc which is tangent to given arc with radii R1 and R2 and with the centers as X and Y. The required radius of a tangent arc is R3. Take X as center and radius equal to R1 plus R3. Draw an arc A', B'. Similarly, take Y as a center, draw an arc C', D' with radius equal to R2 plus R3. The arcs A', B' and C', D' intersect at point P. With point P as center and radius R3, we will draw an arc which will be tangent to the given arcs at points M and N respectively. Let's now erase the unwanted curve segment. And here we go. We have just drawn a tangent arc to given arcs. Another frequent requirement in engineering drawing is to gradually convert a curve into a single line. For example, do you remember this object? For this type of construction, we need to draw an arc tangent to a given arc and a given straight line. So without wasting much time, let's just do it. This straight line AB and arc DC of radius R1 need to be connected with another arc of radius R2. For that, draw a line A-B- parallel to the given line AB at a distance of R2. Now with center of arc DC, draw an arc D-C- of radius equal to R1 plus R2. This arc D-C- intersects the line A-B- at a point P. With P as center and radius of R2, draw the final arc. This arc meets the line AB at point M and arc DC at point N. MN is the required tangent arc. Pretty easy, isn't it? Let's now move further to ogee-shaped arc tangent between two parallel lines. But first, what is an ogee curve? Ogee curve is also known as reverse curve and is a combination of two arcs that are reverse of each other. Now AB and CD are the two given parallel lines. Join points B and C and bisect the line BC to obtain its center point T. Further bisect line segments BT and CT. From point B, draw a perpendicular line to cut the bisector line PQ at E. And from point C, draw a perpendicular line to cut the bisector line RS at F. With points E and F as the center points and radii equal to EB and FC, draw arcs BT and CT. The arc BTC is the required ogee curve. So this is how the tangents are used in engineering drawing. Interesting, isn't it? In this last session on geometrical constructions, we will learn to draw a circle through any three non-collinear points, then divide a circle into equal parts, and then we will construct an ellipse along with a regular polygon. Let's start by drawing a circle through three non-collinear points A, B, C. Join points AB and BC with faint construction lines. Bisect lines AB and BC. Now extend these bisector lines till they intersect each other at T. Take T as a center point and radius equal to distance AT. Actually, if you see, AT, BT and CT are equal distances. So let's draw a circle. Observe that this circle passes through all the points A, B and C. So let's move on to divide a circle of radius R into 12 equal parts. First, draw two diagonals AB and CD at right angles to each other. With A as center and radius equal to R, draw arcs cutting the circle at 2 points 2 and 7. Similarly, with B as center, draw arcs cutting the circle at points 3 and 6. Now repeat the above steps for points C and D to get the intersection points 1 and 4 and 5 and 8 respectively. That's it. You see, we have just divided the circle into 12 equal parts. Alright, so let's take up the next challenge of constructing an ellipse having a major axis of 120 mm and minor axis of 60 mm. With point P as center, draw a circle of radius 60 mm that is equal to semi-major axis. Similarly, draw another concentric circle of 30 mm radius that is equal to semi-minor axis. Divide the outer circle into 12 equal parts and mark dividing points as A, B, C, D, E, F, G, H, I, J, K and L. Similarly, divide the inner circle into 12 equal parts and mark those points as A dash, B dash, C dash, D dash, E dash, F dash, G dash, H dash, I dash, J dash, K dash and L dash. Draw a vertical line from point B and a horizontal line from B dash so that they intersect at a point small b. This point small b is on the boundary of the ellipse. Similarly, draw rest of the lines and mark the points small c, d, e, f, g, h, i, j, k and small l. Draw a smooth curve sequentially passing through these intersecting points A, B, C, D, E, F, G, H, I, J, K, L and back to A. So this is the required ellipse with 120 mm major axis and 60 mm minor axis. So let's take the last challenge of this chapter. Draw a regular polygon. A polygon is a many-sided geometric figure and a regular polygon has all the sides of equal length. We will construct a regular hexagon with its center at point P and side length of 50 mm. First, draw a circle of radius 50 mm from point P. Now draw a horizontal line AD passing through the center of the circle. Then starting with A, we mark points at 50 mm distance on the circle's boundary B, C, E and F. Join points A, B, C, D, E, F and here we go. It's a regular hexagon. So this is how we learn commonly used geometrical constructions in engineering drawing.